Yeah, I'm going to talk about the Koha Geosearch thing. So maybe I should turn that one on. Again, short intro about me, who wasn't there yesterday. My name is Thomas Klausner, or Tom, and that's too small. I'm doing Perl for like a long time, and that's my 19th European Perl conference and my first KohaCon. So that's nice. I'm here as the K from this HKS3, or 3 people doing Koha support. That's Mark Hofstetter, David Schmidt, and me. We started working by accident with Koha in 2020 because a customer wanted to run Koha, and yeah, and we did it. And since then, we worked with some other libraries in Austria, Germany, and Hungary, helping mostly with migrations, starting to host Koha, and providing custom development like this thing I'm talking about here. So this is for a library of Geosphare Austria. That's a very recent merger, which you don't know about because you're not in Austria, of the ZAMK, the Zentralanstalt für Meteorologie und Geodynamik, which cares about the weather, and the Geologische Bundesanstalt, which cares about rocks. So those 2 public institutes have been merged into Geosphere Austria. And this part is about the rocks. And they are like thinking about switching to Koha, but their current library of the Geologische Bundesanstalt has one crucial feature that they need, which is a spatial library search, or aka Geosearch. So that's like the old library system has this weird plug-in thingy where you can start this search and you enter a term like Helsinki, for example. And then they do a GeoNames lookup, which maps Helsinki to like the proper location and suggests some other nearby locations. And then when you select like the city of Helsinki, it does a search on books that are about Helsinki. Not the books are in Helsinki. It's not about where the book is in the library, but what the book is about. And it's not just using this via like a tag, Helsinki, but by mapping Helsinki to a latitude and longitude, like a geopoint, and then figuring out which other books are there and in the neighborhood. So when you search for Helsinki, you only find Helsinki. You also find Jätkäsaari, sorry, for all the Finns. And yeah, and then there's one book in their library about this thing, about anthropogenic impact on recent sediment in the Chakotari Heber Basin. So it's like a bestseller, I guess. And if you then click on Helsinki, you find 56 other books, which are about the rocks beneath Helsinki, I guess. Oops. Okay. Maybe you see some Mastodon reactions to a recent tweet. So can this be done in Koha? Not currently, as far as I know, or as far as we know. But of course, Koha is open source, and we can code Perl. So let's try to add this, at least a prototype for now. So the plan was firstly to find a place where we can actually store the geospatial data, like latitude and longitude, for a book. Then add this data to the search index, and then implement a way to actually search for this spatial data. And then in the end, show the results on a map. That's the bug for this feature in the bug tracker. A side note for the non-librarians here, I'm going to talk about MARC a lot, which is this thing from Wikipedia. So it's a standard set of digital formats for machine-readable descriptions of items. It's a metadata format for books. And MARC has some fields. For example, 100 is the primary author, and 245 is the title of a book. But it has a lot of fields, not just those 2. This is one representation of MARC, which is like ugly and annoying. But you can see you have like the author over there and the title. C, for example, is the statement of responsibility. All of those MARC fields have very weird names for me as a non-librarian, but yeah, you get used to it. And this is MARC XML, which is the same data represented as XML, which is a little bit, I mean, it's XML, so it's not that easy to read, but it's a little bit more self-documenting than when you have to, I don't know, count bits in the other representation. Yeah, so there are a lot of MARC fields and there are different ways to use them based on culture apparently. So depending on if you're an American library or a European library, you might use it a little bit different. So it's a little bit of chaos. And Koha maps some of the more important fields of these things to actual database columns. But a lot of this data is way too unstructured to actually map it to a database. So it's stored as a blob, like the MARC XML as an XML document, which is also quite nice because using MySQL, you can actually query the XML directly using XPath. A topic for now. So Rainer Stowasser, who works for the ZAM, pointed out the MARC field 034, subfield SMT, which you can read about here or in some other places. That's like a documentation of all these fields. So one thing about the librarians, they are very, very like picky and document everything very well. Also the MARC fields. So that's like makes it at least easy to work with. So yeah, this field 034 is called coded cartographic mathematical data and has a subfield SMT for achieving latitude and longitude. That sounds quite well. If you ignore the achieving part, that's like nobody really knows what it is.
You can use another field to say the type of
please ask
Yes.
the microphone. Yes.
Because you can use another field to take with type of geoid do you use.
Yes. Yeah. They're like, for example, there's also this field 255C. Maybe you're talking about that one. I don't know. So that's another place where you could store geographic data. But that's one string, at least from what I've seen from the spec, containing a bounding box. So it's 4 points, not 1 point. And it's not very, and it's a little bit annoying to parse because I don't know if the internal data of the field is actually standardized or just some random string. That's what's in the documentation. And that's like not fun to parse, and we only need points anyway. So for now, we stick with the 034, but in the end, you can use whatever you want. Come to that in a minute. Okay.
And in UniMarc, it could be 206, maybe.
Okay. 206, okay, I'll have to remember that. Yeah. Which, by the way, as you see already, for the non-Koha people, that's one of the reasons why Koha is so complex and big, because it's not like there's this one fixed thing. Another side note about searching in Koha. So a lot of the data is unstructured and stored as this blob, but you still want to search for it. So that data is indexed into an external non-database search index. So you have the database, which you use to work on it, and then another thing which you use to actually search. And the default, and maybe legacy, I don't know, thing is called something called Zebra, which you can read about here. I've never heard about it before I worked with Koha. It's like an inverted index thingy, and it works, apparently. But there's an alternative, which is Elasticsearch, which I've been using a lot for other projects. So that's why we implemented this in Elasticsearch, and especially because Elasticsearch already supports geoqueries. Okay? And I'm not sure if Zebra supports that. I don't know, probably not. So this is like an Elasticsearch query. Elasticsearch queries like use a lot of what's that? That's JSON in that case. Yeah, in that case, and yeah, a lot of intention and a lot of things that you have to do. Match all means okay, get all of the documents and then filter. Reduces the result on a filter. In that case, as a geodistance filter, where you can say, okay, you want everything in 200 kilometers around this point of latitude and longitude. That's just a standard Elasticsearch feature, which solves all of the problems for the searching. But for Elasticsearch to use this Geosearch feature, you have to index your data using a special data type called GeoPoint. It's not a string or an integer, it's a special thing, and you have to define this. Now, Koha provides a nice way to map arbitrary MARC fields to search fields, because at least as I understand it, the search fields are sort of like abstract fields like title, and then you can map them to MARC fields like this. So you can say, okay, title should be whatever is in 130 and whatever is in 245A and B and P. And all of those things will be concatenated together, and then you have like the title data, and that's then indexed. So we want to have something like that to store latitude and longitude. But before we can map that, we have to have defined this new abstract field, which you can do in this administration search engine configuration tab of Koha, where you can first, in the first tab, which is called search fields, you define what search fields you have, and some attributes. Our patch adds this new data type and those two things by default. So if this patch is applied, you have this already, you don't have to do it. And next we have to map the actual MARC fields to these search fields, which you do in the second tab, for example, for bibliographic data, which is a very, very long table. You can see, for example, for author, you have like a lot of fields that could be indexed as author. And here I edited like the latitude and longitude with the 034S and 034T fields. And if you want to have like a Unimark or some other field, you can just edit here, okay? So it's not like we didn't implement this to only work with these fields, but we're using the Koha infrastructure to map arbitrary MARC fields to arbitrary search fields. So you still have all of the flexibility. Then you must always make sure that your framework, which is like, I don't know, the interface you use to edit books or something, allows editing of this. So you have to go to this other form in your setup thing and check this box editor, so you can actually edit this field in the editor. And the same for subfield T. So now you can actually start to enter the Geosphere spatial data. You go to the book, you click on edit, you scroll around until you find this field, and you can enter your data. So yeah, if you save it, this will, in recent versions of Koha, will automatically be indexed by Elasticsearch. So you save, and like a fraction of a second later, you can already query it. We can first test this without using Koha by just calling Elasticsearch directly, because Elasticsearch has a REST API. So you call this endpoint with some data. The data you see here is basically the same I showed earlier. That's just like the JSON representation of the query. So you see you want everything in the distance of 100 kilometers of that point, and then you get back some data. Because in my Koha testing Docker local thing, I added like locations to two books, and now I'm finding those two books. I'll show it in a minute. So Koha provides this Elasticsearch indexer with field data in a very long list, looking like this. So you get like title, and then all of the data, and latitude and longitude, which we just edit like this. But Elasticsearch, because it's like using this Geosearch geodata point, wants the data in a different format, like this. So it's not a key value pair, it's a key and a nested data structure. So we need to write some code to extract this data from this list and convert it into this other format, which is this code. I'm not going into too much detail here. Just get the geopoint fields, figure out if it's a latitude and longitude field, do some ugly regex matching stuff, get the data, and then just basically move it around. So that's converting this data into that data. And if you use this data, send it to Elasticsearch, it will get indexed correctly. Maybe not very beautiful, the code, but it works. Maybe we can work on making it beautiful later. I'm not sure. I mean, as I said, I'm just started very recently with Koha, and I have this feeling that a lot of this search thing is still a little bit, I don't know, complicated by having Zebra backward compatibility or compatibility at all. No, okay, I know, because in yeah, we found this nice comment in the source code. Because so what? Okay, I'm coming to this in a minute. It's so Elasticsearch. Oh, sorry, the slide's in the wrong order, basically. So Koha builds like a search query in a one long string, but Elasticsearch also has like a structured DSL which you can use to do proper queries. And here was this comment that maybe later we can convert this into the more robust and powerful DSL thingy. So maybe now is later. I don't know. Because as I said, Elasticsearch actually wants to use this highly structured DSL to formulate your search queries. You use this format where you say, okay, for example, match. That's I I'd probably say it's going to be answered in the next slide, but I'll answer.
Oh, right. Does Elasticsearch have any performance difference when you do it two different ways?
I don't think so. I think it will convert. So is there a performance query between this way and the other way, which I'm going to show in a minute? Okay. So what this does is, because Elasticsearch has like two different things. One is searching for full text. So if you use this must match title thing, it means, does the title contain the string search anywhere in the title? That's like a fuzzy search, and you can use snowballing and stemming and whatever you want to fine tune this. Same for the content. So this thing search for title contains search and content contains Elasticsearch. But the filters don't use like fuzzy searching. They're like hard lookups on an index, basically. So this has to be, the status is like an enum that can have 10 states, and it has to be exactly that state. Same for ranges for dates, for example, and also the same for the geo stuff. And using all of those things, you can have like very nice queries which match exactly what you are searching for. Elasticsearch also provides this query string query, where you can basically say, okay, you have a query string, and that looks like this, which is just one long string using like a Boolean thing, what you would enter into a search form, basically. And you say, okay, this search is on the field of content. And it also supports named fields and ranges, so you can do like this kind of queries, which is sort of the same as we've seen earlier. So you're searching for title contains Helsinki, and status is published, and published date is blah, blah, blah. And I think, if I read the code correctly, that Koha uses this thing to search. So Koha takes whatever you input it, converts it into that string, which looks similar to what Zebra uses, and sends it to Elasticsearch. And I don't know if the performance of this is, yeah, okay. So, okay. Shall I just repeat it? So you said it's like the Zebra format. Okay. And I'm not sure if the performance of this is worse than the performance of using the other thing. I would assume that internally Elasticsearch converts this into the other format, so maybe it's a little bit slower, but there will only be like the parsing of the query and not like the actual searching. Yeah, but this is not as powerful as the proper search DSL. I mean, I don't know if you've ever seen advanced Elasticsearch query. You just open it and you see blank space because all of the things is in that so wide away, because it's like 20 levels deep that you just don't see it on your default editor. Anyway, and additionally, this geodistance thing is not supported by the query string query, just not supported. So we started to build this thing, and maybe this can be a starting point for using like proper structured Elasticsearch queries in Koha itself, instead of going through this other Zebra thing. Maybe not, I don't know. I'm only going to hand wave over this a little bit, but we identify some parts of the search query that should be used in the DSL, and then we remove them from the query string query, and then convert them to the proper filter DSL, and then rewrite the query to use the filter. So that's a subset of the code. It's ugly and not really 100% correct, I guess, but it was enough for the prototype to prove to the customer that yes, it's working in theory, give us more money, and we can implement it properly. So we're looking for this geolocation for fields, do some matching and splitting to get the latitude, the longitude, and the distance from the query. Generate this data structure I showed you earlier, and add this to the filter. And the idea would be that, for example, here you could have a date range query, could also use something like that. Okay. Another question? And another question or comment, I don't know. Okay.
Well, in fact, the most standard way of Koha building is not to use something like advanced query field like type, but system preference or geoquery on, that probably in description, geoquery only on Elasticsearch, not backward compatibility with Koha.
Yeah. Okay.
With Zebra.
So yeah, there was a question about, or a comment about using a system preference. I'll come to that. And Jonathan has another comment.
Yeah, two things. I don't think we have a guideline for new features added to the search engine, but I think it's all right to add something to Elastic and not to Zebra, especially if it's not supported by Zebra anyway. The second thing is this should be a plugin
Okay.
but not the Koha plugin. A Koha Elastic plugin, something like that.
Okay.
So you could have a geoloc plugin that you will attach to a field. So you have your geolocalization field with the MARC mapping, and this field will use this plugin. So you won't have to hack the query builder PM, but it will be, the code will be separated.
Yeah. Okay. So,
but we need to build this system, this plugin system. So that's
okay. So yeah,
that's how it should be done.
Okay. I'll come back to you later. Yeah, and then okay, this just rewrites the query. So using this, as already was suggested, of course, all of this is hidden behind a system preference called Geosearch. So you go to there and then you enable this thing. So it's a feature flag. Only if you turn this on. Currently, that's only like for the search interface. But if you can pull everything into a plugin, yeah, I'm happy to do that. And if you activate this on the search thing, you have this new box down there, which is ugly and not how anybody wants it. But again, this is just a prototype. And yeah, you enter some latitude and longitude, and you hit search, and then you actually get back the 2 data books I entered first, including a nice map. The map is rendered using leaflet. Yeah, you have the list below, and then of course you click on the pin and get information on the book, and then you click on the book, and then you jump into the search result. Okay. Yay, we did it. Yeah, we also added a new API endpoint, which was pointless, more or less, to load the latitude and longitude of the search result so we can display it on the map. I talked about it yesterday and already learned that there's a much smarter way to implement this API endpoint than we did in our, like, we don't know what we are doing, we just copy and paste old code and hack a little bit on it until it works method. Just anyway, so that's the bug. It seemed to be quite ready, but the more I spend time at the conference, the less ready it gets. Maybe we can turn that around again tomorrow, especially in the case of the search form and some other stuff. Yeah, maybe we can fix it on Tuesday. So any more questions, or was everybody already happy to? Yeah. Well, wait for the microphone.
So actually, I have a couple of questions.
Okay.
First of all, can you just can you go to internet, like open a web page?
Yeah, to prove it, here it's actually running on my machine, so it's actually implemented, not just screen job.
So if
So
you
where do you
go
want to
demo FR.
That?
No. Okay. Demo FR.
No, it's an English keyboard?
Yeah.
Okay. Ah, okay. Oh, that was already there.
AFI dash SA.com. So, crap. So this is, it's not Koha's OPAC.
Yep.
It's OK OPAC. So I've been giving a presentation about what it is yesterday afternoon. So we have a visual for like geographic search somehow. So that was just to show different things. I had questions. Okay, so first of all, how did you choose between doing a patch bug or a plugin?
Well, we we figured out that we need to have a patch to actually add this geo field and stuff like that. And then initially we actually, I think we tried to have a plugin like for the output thing. Yeah.
So it's more like technical constraints,
I'm
things not available in the plugin system.
I guess I'm not 100% sure, but I guess that I mean there was like a database change needed to get this new geo point into the field of available search types. I'm not sure if it's. I mean, I guess it's possible that you can have like a plugin in the plugin instruction, tell the people to use this SQL query to initiate it, but I guess that's not useful. I don't know. And we thought it's like a nice feature to like add to the project in total.
Just found out.
Yep.
I was also wondering. So you have some spatial data, but what do they represent? Like, is it like where the story of the book occurs? Is it where the book was written or published? And
it's scientific data about rocks. Yeah. So most of the time it's where are those rocks they're talking about located. Okay. So it's like what the book is about, not.
But this is like one use case.
Yeah, and of course that's their use case. If you want to have like if you want to index, this is a book about New York. Go ahead. I mean, it's like.
So I was thinking, it could be a great improvement, like to have to be able to index multiple geographic data, like geo story, geo published, geo written, or whatever. So, like you could.
I guess yes.
Have different maps.
Yeah, yeah. Okay. And that, one other thing that we were talking about, but I didn't do it in here, is to not index like the actual book, but maybe have like authorities that are also geo-indexed, and then just have the book link to the authority. But the point is, I mean, you could maybe do a lot of this by just using like tags and say, okay, this is about Helsinki, and you know where Helsinki is, but they explicitly wanted to not only find like Helsinki, but stuff that's around the same area.
Just
yeah.
Okay.
Okay.
I'm done.
Okay. Great. Thanks.
So, any more questions?
Okay. Okay. One more. Yeah. Is this in time? Yeah.
It's awesome that we have time and we have people.
One question. You said you search for geolocation for books related to a place. In MARC, subjects are authorities.
Okay.
So wouldn't it be more relevant to do the geosearch on authorities?
Yes, I was trying to talk about this like 1 minute ago.
Okay.
Yeah. So yes, so one idea would be to not index like the book but the authority, or maybe add the geodata to the authority and then indexing, copy the data from the authority into the book, and again index it with the book, because that's the idea of the index, to get all of the data. Because I don't think that you can. I think you cannot do a join between two tables in Zebra.
That's something we should improve in ElasticSearch probably in the long term.
Yeah.
And just to update what I said at the beginning, in UniMarc that would be in authorities field 1, 2, 3.
Authority field
pretty
1, 2, 3.
easy.
Okay.
In authorities.
1, 2, 3. Okay. Like my password.
Thank you. I just wanted to say I think it will be a nice addition to Koha, and I saw the educators will get excited as well. So we won. Okay. And also that there is a feature that pulls in data from authorities for the sea also. So maybe if you get there, look at that first.
Okay.
See how it's done.
Okay.
Thank you for all the questions. We're kind of running out of time now.
Okay.
So actually, this is more a question for Jubu. So what makes you think it should be a plugin and not in main Koha? Like, it's a way to improve the plugin system?
It should be a plugin in Koha. We have done that for Solar 10 years ago, actually. So we had the plugin system. So you can have processing on different fields. And we had the plugin for ISBN, we had a plugin for titles, plugin for different stuff. And so you could have a Koha plugin that will add Elastic plugin to different fields.
Okay.
Thank you so much. We have officially run out of time. Thank you.